Okay. So a node is created by calling malloc function. Data part, data is entered, and in link part or next part, null is given. Then increment the count because we have added our first node into the singly linked list. So count will be incremented from 0 to 1. And finally, return the new node, whatever means you are wherever you are calling the function, that will catch this new node, means hold point to this new node. So this is about create a function. The next function, here we have function wise, you can just go through when you are preparing also. Create function, insert front, delete front, insert end, delete end. That much only I think. There are 5 functions, and then of course main function which is used to call your all these 4 functions. Of course, implementing stack concept here also using push and pop, we are just calling again insert front and delete front. If you call, it becomes the stack. Anyway, coming to the point, node insertion at the front. Basically, how this insertion happens, I have 3 nodes. Suppose already I have created S node, S node, S node, 3 nodes are there. And like this, I have 3 nodes. First student, I'm just marking, this is first student details, second student details, third student details. When I mean 1, 2, 3, all the details, student name, USN number, all the details will be link here, will be present in the data part. And what will be the third node's next part, ma? Third node's next part?
Null.
Null, ma'am.
Now let us try to do this insertion at the beginning or insert front. So when we are trying to insert front, first step, declare a what is this node temp, and then create function you are calling. Create function, what it does, it will create a node like this, allocate memory for this node, whatever, suppose the 4th student's information, all those will be stored in the data part, and next part it will be having null. This much it will do in create node, it will create a node, and that return the node as node, and which is been pointed by your temp. So this is your temp. Temp will hold the newly created node, which is done by your create function. If start equal to null, and as we know, every node, every linked list will have a special pointer called start pointer, which will point to the first node of your linked list. First node of your linked list. So if start is equal to null, then return temp. This will become my first node, right? So simply what you do, return temp, because in our main function, there is a statement, how we are calling this insert beginning as start is equal to insert front. Like this we will call insert front function, you will call insert front. Like this I will call. So return temp means this will be returned to start. That is start pointer points to the new node. Only one node means that is a pocket. This is how it will be done. But as per our scenario here, we have already 3 nodes, and this 4th node I want to enter as your first node. So this is start is not null. It is pointing to the some other node. Okay, so it will come out of this if loop. It will not go into the if loop. It will come out of this if statement. And here temp equal to temp's link is equal to start. Temp's link part change it to start. Temp's link part, you change it to start. Start is pointing to this, so temp's link will point to this. That is what we mean by this statement. After doing this, return temp. Okay, in my function call where I am calling insert function, I am giving this statement start equal to temp. So when you are returning the temp, start will point to what? Start will point to what after this return temp? Start will point to
Temp,
what?
ma'am.
Yes,
Four.
it will point
Four.
to temp. It will point to this fourth node. Now this became your first node. This becomes your first node. I'll just show that statement for your clarity in our main function. Insert and delete and display stack. Yeah. Start equal to insert friend. This was what I was telling here. You are telling start equal to insert friend, return temp. After inserting return temp, you are saying, right? Insert function, what it does, it returns temp. Temp is pointed by what? Start. So start will point to this. Again, when I want to create or insert a new node at the beginning, same process. It will call the function create, add the new node into it, fifth student's information into it, and put null. This much create function will do. After that, create function returns that to your new node, your insert function. Insert function, what you are doing, temps next. This is stored in your temp. Insert new node, whatever is written, is given by your create node, is stored in your temp. That's what in the statement it was, temp is equal to create. This is how you called the function create. And what does create function do? It will create a new node and return that S node, and which is pointed by your temp. So temp points to this. This node points now in our temp insert friend, what we said, temps next pointed to the start and return temp. Return temp means start will point to this node. So it will be like this each time whenever you are inserting, the node will be inserted at the beginning. Insert at the beginning. The second thing, insertion, deletion from the beginning. Let us see the next function. Sorry. Insertion, delete front. So this statement. Okay. Delete front, what it does, we will just have a look. 1 minute. I'll just clear all these things just for our clarity. We will again go back to the first condition or case, like we have in our linked list 3 student details or 3 nodes. Start is pointing to first student detail. Now I want to delete friend. Delete friend means this first node we should delete it. If start equal to null, print that it is empty and return null. Otherwise, if starts link is null, starts link part if it is null, then there is only one student. This condition, when it will happen, when there is no node or no element in your linked list. And this, when there is only one node in a linked list, you have to print that the student with this particular USN is deleted and decrement your count free. When you are deleting, definitely you will use the function free. When you are inserting or creating, what function we have to use? Which dynamic memory function, dynamic function we will be using, ma'am? Malloc. You are using
Malloc.
malloc. You can, of course, you can also use calloc, but we have gone with malloc. You are freeing the stack. Means first you have to remove this or free the memory occupied by this first variable, first node, and just return null if it is in the case. If it is only one node in your linked list. Otherwise, both the cases are not true in this example. Otherwise, what we should do, temp is equal to start. Means start from the first node. So this is our temp. And you can start equal to starts link. Start equal to, means this is also start. So start equal to starts, this is starting node. Start equal to starts link means this pointer will be pointing to this second node. After making this start equal to starts link, starts link means after pointing the first start address as this, second student's detail, print that this is what you are going to delete USN of that temp and decrement your count and remove the or free the temp variable or temp node and return start. Now start is this node. So that is what, that is how you are deleting at the beginning. First I have to point. Again I want to delete beginning means the starts position point to this next variable. Sorry. Point to this next node, which was your 3. Which was your 3. Then you free this node. Then you free this node. Again, when I want to delete the second condition, if starts next is equal to null, then there is only one element, so we cannot move the start to its next. So free this particular temp and we will just keep quiet. So your full list will be deleted. Will be deleted. So this is the two functions, main insertion. Three functions we have discussed as of now. First function is insertion at the beginning, insertion at the, sorry, deletion at the beginning, and create function we have seen. We will continue the discussion of the same singly linked list in our afternoon lab session. Okay, because actually I need more time for this. Now it's already time. So we will continue the discussion in our afternoon session.